Welcome to this visual explainer. I want you to go ahead and take a deep breath. Just let your shoulders drop, sit back, and let the daily grind totally fade away for a bit. Today, we're going on a really relaxing exploration. We're going to drift into the mysteries of the cosmos in a calm, super accessible way. We'll start right in our familiar backyard, the solar system, and casually make our way out to the absolute mind-bending extremes of space and time. Okay, are you comfortable? Let's dive right in.
This is something I actually think about quite a lot when I'm just looking up at a clear night sky. Do we truly comprehend the bizarre extremes hiding in the dark corners of our universe? We're so used to the everyday laws of nature here on Earth, right? The sun comes up in the east, gravity pulls things down, the ground under our feet feels completely solid and reliable. But as you'll see in this explainer, the absolute second we zoom out into the cosmos, the universe just completely ignores our earthly expectations.
So, let's start with part one. Close to home, our solar system. Now, you really don't have to travel light years away to find things that completely defy common sense. Even our immediate planetary neighbors refuse to play by Earth's rules. Take Venus, for example. Venus rotates so incredibly slowly on its own axis that a single Venusian day takes 243 Earth days. But, and here's the wild part, it only takes 225 Earth days for it to make a full orbit around the Sun. So literally, a year on Venus is over faster than a single day. And if that wasn't weird enough, Venus actually spins backward beneath its suffocatingly thick clouds. If you were somehow standing on that scorching surface, looking up, you'd literally watch the sun rise in the west and set in the east.
Let's just drift a bit further outward to our other neighbor, Mars, to see how things keep shifting. Here at home, we know a beautiful sunset means vibrant oranges, pinks, and reds, with a crisp blue sky during the day. On Mars, that entire color palette is totally flipped. Because of its super thin carbon dioxide atmosphere and all the fine dust particles hanging in the air, a typical Martian daytime sky is actually yellowish. But when the sun starts to dip below the horizon, the whole sky gets bathed in this really serene, icy blue-gray glow. Honestly, a relaxing evening walk on Mars would give you a sunset in the most stunning, cool blue tones imaginable.
And moving out to Jupiter, we see a brilliant example of how gravity can just absolutely torment a world. This is Io, one of Jupiter's moons. Unlike our own quiet, peaceful moon, Io is one of the most violent, volcanically active places in the whole solar system. Why? Well, it's trapped in a massive cosmic tug-of-war. On one side, Jupiter's immense gravity is pulling it in, and on the other, the large outer moons, Europa and Ganymede, are yanking it the other way. Because of these constant crushing forces, Io's crust is basically being kneaded like bread dough. The physical surface of the moon bulges up and down by up to 100 meters. It's almost as if the ground itself is breathing. All that friction creates so much internal heat that well over 100 active volcanoes are constantly erupting, literally repaving the entire surface every few thousand years.
All right, moving on to part two, bizarre worlds and weather conditions.
Okay, so we're leaving the comfort of our solar system now, stepping out into the wider Milky Way to check out some exoplanets. And this is where the universe gets wonderfully creative and honestly a little terrifying. Take exoplanet HD 189733b, which sits about 64.5 light-years away from us. If you were looking at this from a safe distance, you'd think it was calm and inviting. It's this gorgeous, deep cobalt blue that kind of reminds you of Earth's oceans. But man, appearances are deceiving. That blue color isn't water at all. It's from silicate particles in the atmosphere. The daytime temperature is well over 1,000 degrees Celsius, and thanks to some truly insane winds, it rains molten glass. Actually, scratch that. It doesn't just rain, it blasts molten glass sideways at over 7,000 kilometers per hour. That's roughly 7 times the speed of sound. Absolutely stunning to look at, but a totally horrifying vacation spot.
But there's also a certain, almost poetic melancholy out there in the dark. That brings us to rogue planets. We're so used to planets snuggled up safely around a warm parent star, right? Rogue planets don't have that luxury. They were either violently kicked out of their original solar systems early on, or they just formed completely alone out in the void. So now they just drift through the vastness of space in internal, freezing darkness. No star to orbit, no sunrise, just orbiting the center of the galaxy entirely on their own. And the wild thing is, we're discovering more of these lonely wanderers every single year.
Let's dive into part 3. Extreme speed and density.
Now we're going to push into the absolute theoretical extremes of our universe. This is where the quiet, calming vastness of space suddenly gets ridiculously dense, heavy, and unimaginably fast. 716. I just want you to let that number sink in for a second. 716. That is how many times a specific neutron star called PSR J1748-2446 rotates. And that's not per year, it's not per day, it's 716 times in a single second. Literally, in the few seconds it took me to say that sentence, this entire celestial body spun on its axis thousands of times.
To really wrap your head around that kind of madness, because it spins 716 times a second, its equator is moving at about 25% the speed of light. Its density is 50 trillion times greater than solid lead, and its magnetic field, 1 trillion times stronger than our own massive suns. But here is the stat that absolutely gets me every time. Its weight. If you could somehow scoop up just a single tablespoon of material from this star, that one little spoon would weigh roughly 1 billion tons here on Earth. That is literally the entire weight of Mount Everest, compressed onto a spoon you could hold in your hand. It's just staggering how dense the universe can be.
And speaking of extremes, we absolutely have to talk about one of my favorite theories. We all know about black holes, places where gravity is so strong that nothing, not even light, can escape. But physics really loves balance, right? So theorists ask, if there's a place where everything falls inward and disappears, is there a cosmic opposite? Enter the white hole. It's a purely hypothetical object where absolutely nothing can enter from the outside. Instead, it violently spews energy and light outward. Maybe they're hiding somewhere far off in the cosmos, or maybe, just maybe, they're the exit doors sitting at the very end of a black hole. It's kind of comforting, honestly, thinking that the universe might just be perfectly balancing its own cosmic scales. And finally, part 4, the unimaginable great emptiness.
So, we've looked at the heaviest, most extreme places. Now let's completely flip the script and look at the quiet, the unimaginably vast emptiness that truly makes up the cosmos. And here is the coolest part. This emptiness isn't just out there between the stars, it's in you. It's in all of us. If we look at normal baryonic matter, the stuff that makes up humans, stars, the device you're watching this on, it is 99.9999999% completely empty space. Only that impossibly tiny remaining fraction is the actual nucleus of the atoms. Think of it like this. If a hydrogen atom were the size of the entire Earth, the proton in the very middle would only be about 200 meters across. The rest of the entire planet would be literally nothing. We are quite fundamentally built out of empty space. So how does that microscopic emptiness scale up to deep space? Well, here on Earth, we're wrapped in a pretty comforting, thick blanket of air. Down at sea level, just 1 cubic centimeter of air holds about 10 to the 19th power molecules. That's a 1 with 19 zeros behind it. Now compare that to the deep isolation of interstellar space. Out there, you might find just 0.1 atoms in that same cubic centimeter. The space between the stars is, quite literally, the most silent, empty environment we can possibly imagine.
And that emptiness doesn't just happen on a small scale. It pools into these gigantic, desolate bubbles. Take the Boots void. It's this incomprehensibly huge region of space, about 330 million light-years across, where there are basically no galaxies at all. We're pretty lucky the Milky Way is in a crowded neighborhood, because as the saying goes, if our galaxy sat right at the center of the Boots void, we might not have even known other galaxies existed until well into the 1920s or later. If we'd been born in the middle of that immense dead zone, the night sky beyond our local stars would have just been pitch empty black. Early astronomers wouldn't have even seen the wider universe. All right, I want to pause on one final number that is just breathtaking. 10 billion. 10 billion light years. That is the measured length of something called the Hercules Corona Borealis Great Wall. It is the single largest known structure in the entire observable universe. It's this colossal filament, a sprawling web of thousands of connected galaxies and gravitational fields that forms a literal wall across space. Just to put that into perspective for you, the entire universe we can currently observe is about 93 billion light-years across. That means this one single structure stretches across more than 10% of all visible existence.
And that brings us to the final thought I want to leave you with today. Just something to quietly ponder. Knowing that you are made almost entirely of empty space, floating on a lovely blue marble where our days and years make sense, completely connected within a cosmic web of galaxies that spans billions of light years, how does all of that change your perspective of your place within it? Doesn't it make the emails, the traffic, and the daily stress down here on Earth feel just a little bit lighter? I hope you let that thought guide you today and that it brings you a real sense of relaxed wonder. Thank you so much for joining me on this explainer. Take care of yourself out there, and hey, don't forget to look up every once in a while.